All right, trigonometric substitution, one of, if not the hardest topic in higher level math, in my opinion, maybe not most. Okay, so we start with this. This is how I do this. We start with x equals sine theta. Okay, and then I say, let's do dx equals cosine theta d theta. And then, basically on the side, we're just going to put a whole bunch of stuff that's going to help us solve this. Okay, so we're going to start with a triangle. So if x equals sine theta, so this is theta, we've done this before, then this is x, this is 1, and this is 1 minus x squared. Okay, so that means that if I'm going to go a little bit further, I have cosine here. So I'm going to eventually need to know what cosine is. Cosine theta is equal to adjacent, which is this piece, divide hypotenuse, which is 1. Okay, so I'll start with this. Maybe I need a little bit more. Maybe I'll need tangent, but I don't think I will. So we'll start with that. Okay, so now we can do some substitutions. So here we go. Square root 1 minus x squared. X is sine theta. So 1 minus sine squared theta. And dx, taking out the dx and substituting in cosine theta d theta. Okay, you should know from your formula booklet and your dozens of years of mathematics that 1 minus sine squared is cosine squared. So this is cosine squared. And that's still cosine theta d theta. So the square root of cosine squared is cosine times cosine again. We're going to get cosine squared. So this whole mess simplifies to cosine squared d theta. Now, taking the integral of cosine squared isn't easy, but we'll just do a little bit of background for a second. We have cosine. This is actually called a reduction formula. It's nothing more than just the double angle formula. I'll just go over here and do some side notes. Cosine 2x, if you remember, is 2 cosine squared x minus 1. That's straight from your formula booklet. There's 3 options for the double angle, this being one of them. You see here, there's a cosine squared. There's a cosine squared here. So I'm going to solve for cosine squared. So I get cosine 2x plus 1 all over 2 equals cosine squared. Okay, so now I can take out cosine squared and I can substitute this piece in. So I have integral, I'll pull the 1/2 out, cosine 2x plus 1 dx. Okay, and now this should be pretty easy integral to take. I have, make some room here, I have 1/2. The integral of cosine 2x is 1/2 sine 2x. And the integral of x is just, sorry, the integral of 1. Ooh, I'm changing all sorts of things. I'm sorry. This is supposed to be a theta. This is supposed to be a theta. And this is a theta. So then plus theta. And plus c. All right, so there's our answer in terms of theta. Well, the original was in terms of x, so I need to go and plug some stuff back in. Sine 2 theta, I'll make a little side note here, I'm running out of space. Sine 2 theta is another double angle, and that's 2 sine theta cosine theta, taken right from your formula booklet. There's only one double angle for sine. Okay, so now I think we can finish this up. We have 1, let's see, 4th, no. Sorry. Okay, sine 2 theta is 2 sine theta cosine theta, and I'm going to multiply that by 1/2, which means that 2 and that 1/2 is going to cancel. So I still just have this 1/2 out in front. And then sine 2 theta is sine theta, which is x. And cosine theta, which is root 1 minus x squared. I'll put a little parentheses around that so it doesn't look like it multiply. Plus, and theta, well, what's theta? Go back here, take the arc or inverse sine of both sides, and we have theta is equal to sine inverse of x plus c. Believe it or not, that is the integral of this. It looks nasty, it is nasty, but that is the answer. So, there's your first example with integrals with trigonometric substitutions.